Yes, hi guys. So again, I'm taking the same topic, tracing of the curve for Cartesian coordinates. Okay. Well, polar coordinates is still away because in the next lecture series I'll take for polar coordinates, curve tracing for polar coordinates. Okay. Then for parametric equations, etc. But at the moment I'm taking some more questions regarding curve tracing in case of Cartesian coordinates. Okay. So curve tracing for Cartesian coordinates, I've taken some more questions because these questions were discussed in the class also. Okay, students have asked me some more questions, that do some more questions so that they can get mastery over this subject, because there are certain points still not clear to the students. So that's why I've taken these questions. Okay, more questions I've taken. These 14 questions I'll do, which are also based on the same curve tracing, on curve tracing in case of Cartesian coordinates. Okay, so everything I've already described in the previous lecture series, but now I'm taking these questions directly. So question number 1. Now this is further curve tracing further. Okay, I've taken this and all 19 questions I took in the previous lecture series, and all those questions now these are some difficult questions, or further I've taken some questions more. Let me discuss about them. Some are just similar to the previous one, but most of them are different. But let me take question number 1. How to question number, tracing the curve, this y square equal to, y square into, this is y square into, given curve is a plus x is equal to x square into 3a minus x. Okay. Now in this case, what we have to do, again, that the curve is, okay, now this is symmetric to y axis, sorry, x axis, but y is even forward. So first, we always do, let me take, in this case also, the curve is symmetric, first point, the curve is symmetric, about x-axis, Why? Because y is even forward, x is not, because x is here, this is x cube, okay, x is here, there, okay, but here x is also there. So x is not even forward, but y is even forward. So the curve is symmetric about x-axis as y is even forward, or power of y is even number. Okay, this is what curve is. Second point, is it passing through the origin? Yeah, it is passing through the origin because there is no independent constant term. It is passing through the origin. It is passing through the origin. As there is no independent constant term of constant independent term. Independent constant term. You may say independent constant term. Right here, there is no independent constant term. So we can say here there is no independent constant term. Okay, because of that, the curve will pass to the origin. Okay, whenever there is independent term, the curve is not passing to the origin, but this is the same kind of situation here. So this is second point. Third point, which we already defined. Now substituting y equal to 0. Now putting y equal to 0, we get in the given equation this point with y square 0 or y 0, we put here x square into 3a minus x equal to 0, imply that x equal to 0 and x equal to 3 points 0 0, as I tell you that 0 origin is lying upon this, and then next point is 3a and 0. Curve is crossing or intersecting the axis of x at point 3a. Okay, now let us check whether the tangents are lying at this point and what are the tangents. So substituting the origin to this point of shifting. Now shifting the origin to the double point 3a 0. What we do? We substitute value in place of x and y. X we will replace by x plus 3 and y by y only, because y plus 0 is y. So replacing this from first, shifting the origin to the onto this from first equation. From first we get, what do we get from first? This is y square as it is. Here it is a plus 3a plus x, or x plus 3, okay, equal to, this is x plus 3a whole square, and this is minus x only, because in place of x we replace 3a minus x, that means 3a minus x will be negative value. It will be x plus 3a whole square into minus x. Okay, so, and this is y square into 4a plus x is equal to this value. Now in this case, if I equate, this is x plus 3a whole square into minus x. If I open this whole square, we will get 9a square independent term, but if we multiply by minus x, we will get x equal to 0. So equating coefficients, smallest degree term, equating the coefficient of small degree term to 0, coefficient of smallest degree term or terms to 0. We get here, what do we get? This is x equal to 0. Why x equal to 0? Because minus x equal to 0. If I open this whole square, we will get x square plus 9a square plus 6xa or ax into minus x. So if I multiply 9a square by x, we will get minus 9a square into x. This is the smallest degree term. Okay, so that is equal to 0, that means x equal to 0 is the, okay, tangent at the point x equal to 0. That means there is the axis of y, the new, because the new axis of y at 3a 0 will be the tangent line which will be parallel to the original y axis, which will be the tangent line or tangent parallel to old y axis or previous y axis. That's, now let me describe this figure here. So what is that figure? And if I equate from this equation, here it is x equal to minus a also, coefficient of y square from the given equation. So that let me also equate. So we have obtained x equal to 3a 0. So curve is intersecting. First of all, at this point, let me take this as 3a 0 point. Now at this point, as I did tell you, that y axis parallel to the original y axis is the tangent line at this curve. Now why this is why this kind of, no type of curve is there. So now it says that at x equal to minus a, for a plus x equal to 0, if I put the coefficient of y square, smaller degree term here, that will be y square equal to 0. This is x equal to minus a, or minus a and 0. Okay, so if I find out value of y square from the given equation, y square equal to, from the given equation, this is x square into 3a minus x divided by x plus a or a plus x. Now, as x tend to, okay, here x is greater than minus 3a or lesser than or negative value. Suppose 3a greater than 3a, x is greater than 3, then this value will be negative. Or x greater than 3, x greater than 3, y square is negative. What the point? If I put here x greater than 3, that means 4a, 5a, which will be negative value. Y square will be negative. That means the curve will not exist beyond x equal to 3. So the curve will not exist beyond x greater than 3. There is no curve here. Okay, after the x-axis, x dash axis, y-axis, origin O, y dash axis. Now if I take like this, okay, and this is the asymptote is x equal to, because at x equal to, if I put x equal to minus a here, it will be 0, y tends to infinity. Y is plus minus infinity here. So y is equal to plus minus x under root 3a minus x upon under root a plus x. If I put x equal to minus a, it is something upon 0 is infinity. Y tends to plus minus infinity. Y is equal to plus minus infinity at x equal to minus a. This is minus a. So therefore, the curve is intersecting at O origin, meeting at the origin at as well as 3a minus 3a 0. And at x equal to minus a, there is a asymptote here. What is the asymptote? X equal to minus a is the asymptote. So x equal to minus a, let me write here, is an asymptote. At which when x tend to minus a here, minus a, y square tends to, or y tends to plus minus infinity. Y tends to plus minus infinity. That x equal to minus a, this is y tends to, the curve is coming to the extended, this is, or meeting at the asymptotes at infinity. This is what kind of curve is here. This is the curve which we have taken here, and beyond this line x equal to minus a, there is no curve. Because if I put here minus 2, minus 3, then it is not defined. It is managed by imaginary. So beyond x equal to minus a, curve will not exist. Beyond 3a, x equal to 3a, curve will not exist. So this is the shape of the curve. Question number 1. We have done here question number 1, and this is the shape of the curve here. So x equal to this one from the original equation. We have taken this y is equal to x square into 3a minus x upon a plus x. Then from this we just assume that if x is greater than 3a, then the curve will, the y will be negative, okay, or then curve will not exist beyond x equal to 3a. There is no curve here. Curve is meeting at x equal to 3a. That means curve is going like this, okay, and at x equal to minus a, y is infinite, plus infinity minus infinity. So this curve is meeting the axis. The x equal to minus a, the asymptotes at infinity. So x equal to minus a is the asymptote here. Okay, this is the tracing of the curve. Question number 1 we have done. Now in this case, what we under asymptote is here. We have just taken that x equal to minus a is an asymptote here. Tangent here by at the curve at the point x equal to 3a. The tangent is y-axis, because y-axis is at y-axis we find x y equal to 0. Here it is, and x equal to 0. We found that x equal to 0 was the tangent at this line. So x equal to 0, that is y-axis. Y-axis is parallel to the origin y-axis. This is origin y-axis. This is O. Origin here equal to 0. Okay. This is the shape of the curve. Question number 1. Now let me take question number 2. What is question number 2 here? Let me check it. Okay, question number 2. Let me see what does it say. Okay. Now question number second. Now first is over. Shape is clear. Now second question. Trace the curve y square into a minus x. Okay. And here it is x square into a plus x. Let's discuss about this point. This kind of question we have previously done in this section. So question number second is also the curve is here y square into a minus x is equal to x square into a plus x. Again, the curve is symmetric to x-axis y, because x is odd number and y is even power. So first and foremost thing you always say that curve is symmetric to axis of x as it was here. Okay, so same here. First point, curve is symmetric about x-axis as y is even power, or power of y is even, and y is even power. Okay, or power of y is even. So this is y square here. Otherwise, x is x cube. Here, x is there. So same kind of question. Second question we have taken here. Okay. Now, let me discuss other point. Second point: is it passing through the origin? Yes, it is passing through the origin. It is passing through the origin. It is passing through the origin. Why? Because there is no independent constant term. As there is no independent constant term. Why independent constant term? Because variables are multiplied to each term. Here a is multiplied by y square, x a is multiplied by x square, and x cube is there. So I mean no term is found, constant term which is independently expressed. So independent constant term is not available here. Because of that, the curve will pass through the origin. This is the obvious thing. Okay, so curve is passing through the origin. Now let us put 3 y equal to 0. Putting y equal to 0. Putting y equal to 0. So what do we get? Here, a plus x is 0 or x square. Imply that x square into a plus x equal to 0. From this, x equal to 0 and x equal to minus a. What are the points? 0, 0 origin, and this is minus a and 0. Y coordinate is 0. After substituting y 0, we obtain these 2 points. Shifting the origin to this point, it means at this point, the curve is crossing the y-axis at minus a 0. So the x coordinate is minus a. We just discussed about this. So shifting the origin next. Next point is shifting the origin to minus a and 0. We get, what we do, we put these values minus a, x minus a and y plus 0 in the given equation. This is first equation here. So putting the values, okay, replacing, let me write here, replacing x by x minus a and y by y and y by plus 0, that means y only equal to y only in first. So we get, what do we get in the first? Only y square, no change. But in case of x, we substitute. Okay, this is a minus x minus plus a. Okay, so this is equal to x means a minus x or x minus a. X minus a whole square. In bracket it is a plus x minus a. Minus x is out. And this is, now from this equation what do we get? X is independent term here. Because x is the smallest degree term, so equal to 0. Equating the smallest degree term of this equation 0 0, what we get. But in this case, if I open x minus a whole square, this is x into x minus a whole square. If I open x minus a whole square, we will get x square minus twice ax plus a square into x into a square, coefficient of x is a square, equating that equal 0. So x equal to 0 here, x equal to 0. Again, y-axis, it means x equal to 0 is at y-axis. So y-axis, so the tangent at minus a 0 is the new y-axis. Is the new y-axis parallel to the old one, or old y-axis. This will be just described. Okay, so this is one case that curve is passing through the origin, that is also there, vertical 0 and minus a and 0. Curve is meeting at this point. Now beyond this, what is the value of y then for solving this equation? Let me solve the equation given. Now, what are the asymptotes? Let me talk about that also. So in this case, solving first for y. So y square is equal to x square into a plus x divided by a minus x. So what we see, now if I take x greater than a or lesser than a here in this case, because a is a minus x. If I take x beyond a, if I take 2a, 3a, etc., it will be minus 2a, minus 3a. If I take x beyond this, okay, or x is here minus a, if I take a equal to minus a, this is a plus a, no problem, but here it will be 0, y is 0 in that situation when x equal to minus a. So the value of x is lying between minus a to plus a. The minus a to plus a, x minus a is lesser than x is less than a. This is one of the situations. Now in this case, when it is negative, if I take x 2a, 3a, etc. Okay, so if I take x 2a, 3a, etc., then this is negative. So beyond this point, the curve will not lie. The curve will not be there. So a minus x equal to 0. If I take at x equal to a, y square tends to infinity. If I put x equal to a here, okay, so beyond a we cannot take, so because y tends to plus minus. Now if I find y here, y would be then plus minus infinity. Y tends to plus minus infinity, not infinity. It is y square tends to infinity or y tends to plus minus infinity. That is what at x equal to a. So beyond a, in this case, x equal to a is the asymptote here. Asymptote is x equal to a or x minus a equal to 0. This line is the asymptote here. So, okay, and beyond x equal to minus a also, the curve will not exist. Why? If I put x equal to minus 2a, minus 3a, etc. here, minus 2a if I suppose if I put, it will be negative then. At x equal to minus 2a, minus 3a, etc., y square will be negative. Y square will be negative. Y square will be negative. So beyond minus a, x equal to minus a, the curve will not exist. The curve will not exist. Let me tell you one thing. The curve will not exist. Because beyond that curve will not exist. It means curve is lying between minus a to plus a. Curve will not lie between curve is lying between minus a and plus a. This is the range here. Beyond minus a and beyond x equal to a, the curve is not going through, is not existing. So that is, let me now express. So the curve, then what will be the curve in this situation? From the curve I will take everything. I will verify everything there. So put the curve here. Now in this case, in this situation, here we have, this is the coordinate axis, x-axis, x-axis, y and y-axis is the origin. Now in this case, it says that at x equal to minus a, this is minus a and 0 point. At this point, y-axis is the, this is the y-axis is the tangent at this point. Now the curve will be like this, passing through the origin. Okay, and at this point, because here the curve is, it will not be equal to a, because if it is a, then extend to infinity, because this is dotted line. If we take here, it is dotted line here, because if it extend to a, so this is asymptote here, x equal to a is the asymptote. Is the asymptote here. Okay, so this is x equal to a, that means a0. And these are the lines, still lines, x equal to a, this is y equal to minus x, and this is y equal to plus x. Y equal to x. We have two tangents which are intersecting. So we may say distinct tangents are possible here upon this curve. So minus 8. So this is the tracing of the curve here. Okay. Let me change this marker. Alright, so x equal to a is the asymptote here, that I would be written. X equal to a is the asymptote because the curve is meeting the asymptote at infinity. It seems to meet at infinity. So this is the asymptote x equal to a. So beyond that, the value is not existing. Beyond minus a also, the curve will not exist. This is the tracing of the curve here. Okay. Simple. What we do, we shift the origin to minus a 0, we shiftable from 0, 0 to this. So this is the new origin. At this point, we find out the tangent. Tangent is now parallel to the y-axis. Okay, this is parallel line or new y-axis at the point x equal to minus a and 0 at this point. Y-axis is the new tangent line. Okay, a new tangent. Now this tangent is parallel to the original y-axis. This is the y-axis here. But at this point, y is 0, x is 0, sorry. X equal to 0 was the tangent line, but that means x equal to 0 was tangent. That means y-axis is the tangent to this point minus a0. This is the tracing of curve. Question number 2 we have done. Okay. Asymptote is x equal to a. This is the asymptote here. Now let us talk about, because at x equal to a, even if I put a, this is dotted dark line, because x equal to a is here. At x equal to a, y is plus minus a. So this is plus infinity and minus infinity. Y is plus infinity and minus infinity at this asymptote. This is question number 2 we have done. Now let me talk about question number 3. What is question number 3 here? Let me check it. Okay, so we just find out what is symmetric, curve is symmetric or not, it is passing through the origin or not, okay, or what kind of tangents are there. Now let us talk about our question. Now question number 3 is of what kind? Okay, now here trace the curve. This is volume of Descartes. Okay, so this is y cube plus x cube. curve is y cube plus x cube is equal to 3ax by 3ax by. Now in this case, if I change x by y, y by x, there is no change. I mean, no change in the variable, no change in the equation. Equation will remain same. If I change x by y, y by x, then the curve even x by minus x and y by minus y, if I replace, then also the curve, no, then it will not be there. But if I replace x by x and y by y, because negative if I put, then this is negative, here it will be positive, so that will change. Only if I replace the solution. So if I replace first point, if we replace, if we replace x by y, or we put replace x by y and y by x, then there is no change in the equation. There is no change in the equation. In the equation of the curve. So what is the symmetry? Symmetry here. The curve. So curve will be symmetric to x equal to y equal to x axis. Y equal to x, the straight line. So the curve will be symmetric. The curve will be symmetric to the line y equal to x. This is, we have clarified in the beginning of definition of the previous lecture series, that what is symmetry means. Symmetric, the curve is symmetric if we replace x by y and y by x, there is no change in the given equation. You see here, x cube will remain, y cube will remain, and 3axy will also replace it. X is y, y is x, same thing will remain, so no change in the equation. That means this is a symmetric equation to y equal to x line. We will just discuss about this. Symmetry is there. Now, is it passing through the origin? Yes, it is passing through the origin. It is passing through the origin. It is passing through the origin. Passing through the origin. As there is no constant independent